Part C. Answer any 3 questions. 20th question. Explain the functional units of 8085 microprocessor architecture and its operations. The microprocessor is a programmable device designed with registered flip-flops and timing elements. Architecture. The process of data manipulation and communication is determined by the logic design of the microprocessor is called the architecture. All the various functions performed by the microprocessor can be classified in 3 general categories. Microprocessor initiated operation, internal operations, peripheral operations. Microprocessor initiated operation and 8085 bus organization. The MPU performs primarily 4 operations: memory read, memory write, input output read, input output write. Reads the data from memory, writes the data into memory, accept data from memory input device, send the data to output device. 8085 MPU performs the function using set of communication line called buses. The address bus, data bus, control bus. Buses are shown in the grouped called a system bus. Address bus is group of 16 lines generally identified to A0 to A15. The address bus is unidirectional. The 8085 bus structure is displayed on the screen. Data bus. Data bus is group of 8 lines used to data flow. These lines are bidirectional data flow in both direction between the MPU and memory and peripheral devices. Control buses is composed of various signal lines to carry synchronization signal. MPU uses such lines to perform the third function providing timing signals. Internal data operation and 8085 registers. Internal architecture of the 8085 microprocessor determine how what operations can be performed with the data. These operations are store 8-bit data, perform arithmetic logic operation. Third one is test for conditions. Fourth one is sequence the execution of instruction. Fifth one is store data temporarily during execution. Define read-write memory locations called this check. The 8085 programmable register diagram is displayed on the screen. Register. The 8085 has 6 general purpose register to perform the first operation in list above, that is store 8-bit data during program execution. This register defined as B, C, D, E, H and L. Accumulator. The accumulator is an 8-bit register that is part of the arithmetic logic unit. This register used to store 8-bit data to perform arithmetic and logic operations. A result of the operation is stored to the accumulator. Accumulator also defined as a register A. Flags. ALU include flip-flop. 5 flip-flops that are set or reset according to the result of an operation. Microprocessor uses to perform third operation, namely testing for data conditions. Program counter 16-bit register deals with fourth operation, sequencing the execution of the instruction. This register is memory pointer. Stack pointer is also the 16-bit register. The memory pointer initially it will be called the stack pointer register. The emphasis is that is the register registers. It points to a memory location. Read-write memory called the stack. Peripheral or externally initiated operation. External device can initiate the following operations: reset, interrupt, ready, hold. Reset. When the reset pin is activated by external key is also called a reset key. All internal operations are suspended and program counter is clear. Now the program execution can again begin the 0 memory address. Interrupt. The microprocessor can be interrupted from the normal execution of instruction and asked to execute some other instructions called a service routine. The microprocessor resumes its operation after completing the service routine. Ready. The 8085 has a pin called ready. If the signal is a ready pin is low, the microprocessor enter into a wait state. This signal is used to primarily synchronize lower peripheral with the microprocessor. Hold. When the hold pin is activated by the external signal, the microprocessor relinquishes control of buses and allow the external peripheral of use them. For example, hold signal is used to direct memory access DMA data controller. Data transfer. 21 question. Write an 8085 AL program for 8-bit subtraction using complement. MVI C,00 initialize C200. LDA 5000 load the value to accumulator. Move B, A. Move the content of accumulator to B register. LDA 5001 load the value of accumulator. B. Subtract content of B register from accumulator. JNC loop. Jump on no carry. CMA complement accumulator content. INR A. Increment value in accumulator. INR C. Increment value in register C. Loop STA 5002. Store the value of A register to memory address. Move A, C. Move content of register C to accumulator. STA 5003. Store the value of accumulator memory address. HLT. Terminate the program. 22nd question. Explain the addressing mode. Each instruction requires certain data on which it has to operate. The various format of specifying operands are called the addressing mode. The 8085 instruction set as the following addressing mode. First one is direct addressing mode. Second one is register addressing mode. Third one is register indirect addressing mode. Fourth one is immediate addressing mode. Fifth one is implicit addressing mode. First one is direct addressing mode. In this mode of addressing, an address of operand is given in the instruction itself. For example, STA 8500H, it stores the content of accumulator in the memory location 8500. Second point is register addressing mode. In this addressing mode, operands in the general purpose register. Example, move A, B, add B. Register indirect addressing mode is in this mode of addressing, the address of the operand specified into a register pair. Example, LXIH 8500, load the content of memory location of HL pair. Move A, M, move the content of memory location to accumulator. Fourth one is immediate addressing mode. In this mode of addressing, operand given the instruction itself. For example, MBA A, 05, the value 05 is moved immediately to the accumulator. Fifth one is implicit addressing mode. With some instruction the operand are not given, they operate on the content of the accumulator. For example, CMA, RAL, RAR. CMA is complement of accumulator, RAL is rotate accumulator to left, RAR is rotate accumulator to right. 23rd question. Explain about 8255A programmable peripheral interfaces. The 8255A is general purpose programmable input output device designed to transfer the data from input output to interrupt input output under certain conditions are required. It can be used with almost any microprocessor. It consists of 3 8-bit bidirectional input output port, which can configure as per the requirement. Port of 8255A, 3 ports, port A, B and C. Port A contain 8-bit output latch buffer and 8-bit input buffer. Port B is similar to port A. Port C can be split into 2 parts, port C lower, PCO, PC3 and port C upper, PC7, PC4 by the control word. These 3 ports are further divided into 2 groups. Group A includes port A and port C. Group B includes port B, lower port C. 2 groups can be programmed 3 different modes. The first mode is named mode 0, second mode is named mode 1, third mode is named mode 2. Operating modes. 8255 has 3 different operating modes. Mode 0, mode 1, mode 2. In this mode, port A, B used to 8 bits port C 4 2 bits ports. Each port can program either input mode or output mode, where output latch, input not latch. Port do not have interrupt capability. Mode 1. In this mode, port A, B and used to 8-bit input output port. They can be configured either input or output ports. Each port use 3 lines. Port C handshake signals. Input and output are latched. Mode 2 is in this mode, port A can be configured the bidirectional port B, either mode 0 or mode 1. Mode A uses 5 signals from port C, handshake signals for data transfer. The remaining 3 signals from port C can be used either as simple input output handshake for port B. Features of 8055A. The prominent features of 8255A is as follows. It consists of 3 8-bit input output port, for example PA, PB and PC. Address data bus must be externally demuxed. It is TTL compatible. It has improved DC driving capability. 8255 architecture diagram will display on the screen. Pin diagram also display on the screen. Data bus buffer, a tri-state 8-bit buffer which is used to interface the microprocessor system bus data. Data is transmitted received by the buffer as per as the instruction by the CPU. Control words and status information also transfer using this bus. Read-write control logic. The block is responsible for controlling the internal external transfer for data control status word. It sets up the input from the CPU address control bus and turn issues command both the control groups. CS, it stands for chip select. A low on this input select chip and enables to communication between 8255A and the CPU. It is connected to the decoded address and A0 to A1 and then connected the microprocessor address bus. The CS-A1 A0 result will be displayed on the screen. WR stands for write. Control signal enable the write operation when the signal goes to the low the microprocessor write into a select input output port or control register. Reset, this is an active high signal. It cleared the control register and set all ports in the input mode. RD stands for read. This control signal is enabled to read operation when the signal is low. The microprocessor read the data from selected input output port of the 8255. A0 and A1 and then read write CS result. This tabular column will display on the screen. And then 24th question, describe the DMA memory interface. Direct memory access. DMA transfer the block of data between the memory and peripheral devices to the system. Without the participation of the processor, the unit that controls the activity of accessing memory directly is called a DMA controller. The processor relinquishes the system bus for few clock cycles. DMA controller can accomplish the task of data transfer via the system bus. In this session, we will study to brief the DMA controller register advantages and disadvantages. Uses of DMA. DMA is mode of data transfer between the memory and input output devices. It happens without the involvement of the processor. We have two other methods of data transfer, program input output, and interrupt driven input output. Let's revise each of the get acknowledgement with the drawbacks. In programmed input output, the processor keeps scanning whether the device is ready for data transfer. If the input output device is ready, the processor fully dedicates itself in transferring the data between input output in memory. They transfer a data to high rate, but it cannot get involved any other activity during the data transfer. This is a major drawback of programmed input output. In interrupt divide the input output whenever the device is ready for data transfer. It raises an interrupt of the processor. The processor completes executing an ongoing instruction saves to current state. It then switches to data transfer, which causes a delay. The processor doesn't keep scanning for peripherals ready for data transfer, but it is fully involved in the data transfer process, so it's also not an effective way to data transfer. The DMA controller transfers the data into three modes: burst mode, cycling stealing mode, and then transparent mode. Direct memory access controller and its workings. DMA controller hardware unit that allow input-output device to access memory directly without the participation of the processor. We will discuss the working of the DMA controller. Below we have the diagram of DMA controller to explain its working. Direct memory access control. Input-output device want to transfer a data from memory. It sends DMA request. DMA controller. DMA controller accepts a DRO. The CPU holds the few clock cycle of sending it its hold request, HLD. CPU receives the hold request. A DMA controller relinquish the bus and send the hold acknowledgement of DMA controller. When the data transfer accomplished, the DMA interrupt know the processor data transfer finished to can take a control over the bus again, starting processing where it's left. Direct memory access after the controller, and then below the block diagrams in a controller. The first information has to be read from memory, data has to be written in the memory, and via read and write control lines between processor DMA control of logic unit. The processor send the word count. For example, how many words are to be read or written. It stores this information the data count or the word count registers. Direct memory access order advantages and disadvantages. Advantages means first one is transferring the data without the involvement of the processor will spend up the read write task. Second one is DMA reduce the clock cycle request to read or write block of data. Third advantage is implementing DMA also reduce the overhead of the processor. And then disadvantages is as it is the hardware unit, it would cause the implement of DMA controller in the system. Cache coherence problem can occur while using the DMA controller. Second year BCA Computer Organization Model Question Paper 2 completed.